(7.1) Trigonometric ratios and identities. A. State trigonometric ratios of sin theta, cos theta, and so on example 1. This is the first part of the trigonometric functions. We are going to learn and revise again on trigonometric ratios and identities. As we know, we have this right angle triangle. Okay, and then we know that we have this angle, the blue one, and we know this one is the opposite sides, and this one is the adjacent side to this angle, and this one, the longest one, we call hypotenuse. And for that, we know that sin theta is this theta opposite over hypotenuse. So it's opposite over hypotenuse. And for the cos, we know that it's adjacent over hypotenuse. And we label it with the O, A, and H. And tangent, we have opposite over adjacent. This is the theta, tangent of the theta, opposite over adjacent. So in simple, we have so, ka, toi. We need to remember this for our whole life. That one. And then we came to know cosecant, which is 1 over sin theta. It's just reciprocal of it. We have sin theta O over H, and 1 over sin theta is just equal to H over O. And whereas for the secant, we know that 1 over cos theta, which is reciprocal of the cos. We have H over A. And then we have cotangent, which is 1 over tangent theta. We are going to have the reciprocal of it, which is end up A over O. And for this one, sine and cosecant, secant and cos. For me, I remember it like this. If is C here, cosecant is C, and then you have S. We need to have both. If here is cosecant, we have sine. Okay, if secant, S here, so we are going to have 1 over cos. Okay, so it's one of the ways on how to remember it correctly. You may have another ways of remembering it. And it follows that tangent theta equal to sin theta, because we know that sin theta is O over H and cos theta is A over H. So which is we can cancel this and end up with OA, which is just equal to this one. Okay, and reciprocal of it, cotangent, which is cos theta over sin theta. Okay, now we are going to learn how to get the trigonometric ratios for this angle. Okay, let's look at sine 90 degree minus theta, and we know sine is opposite over hypotenuse. For this angle, referring to this angle, specific this angle, opposite. The sides opposite to this angle is A. This is the opposite of it. Okay, opposite, which is opposite over hypotenuse. And A is A over H. Why we wrote A here, although I said it's opposite? Because this side, okay, is the opposite to this angle, but then it's labeled by A. Okay, why we label A? It's just the same like this one, because of the theta here. Okay, we want to compare with this angle, that's why we stick to the same labeling. Okay, and then A over H. A over H, as we look at here, A over H is just the same with the cos theta. So we know that this is just equal to the cos theta. Okay, and look at the cos 90 degree minus theta. And for the cos, the formula is adjacent over hypotenuse. And the adjacent side for this angle is this one. And it's labeled by O. and hypotenuse still by h. And OH, as we see here, OH is this one, which is just equal to sine theta. So, and this is just equal to with the sine theta. And for the tangent, we know the formula is opposite over adjacent. So we look at the opposite over adjacent, and the opposite of this angle is A. Okay, and the adjacent sides of this angle is O. And we look at A over O is just equal to cotangent theta. And this is just equal to cotangent theta. And we know that cosecant, which is 1 over sine 90 degree minus theta. And we already know that sine 90 degree of theta, this one, is just equal to this, that one. So we can replace it 1 over cos theta, which is 1 over cos theta, this one, equal to secant theta. And then we look at this secant, and we have S here, so we are going to have C here. Okay. Cos 90 degree minus theta, we already did it, which is this one, will equal to this one. I should have used different color. For the cos 90 degree minus theta, we know that this is just equal to the sine theta, so 1 over sine theta. And we know that 1 over sine theta is cosecant theta. And for this one, we know that 1 over tangent 90 degree minus theta. And tangent 90 degree minus theta is cotangent theta. Cotangent theta. And which is end up will equal to tangent theta. This one is just equal to this one and this one. And then, okay, this one, this one. Okay. Okay, we move to example 1, number 2. If cos theta is equal to 3 over 5 and theta is an acute angle, this is the keyword, acute angle, without using calculator, then we know that we are going to use the ratios, and we need to find all of these informations. So first of all, because we know that the information given to you is cos theta equal to 3 over 5, and without using calculator, that means you are going to need a triangle, a right angle triangle, this one, and you let theta be here. It can be here, up to you, but I put it here. And we know that cos theta, and cos is ka, so ka tua, ka, so adjacent over hypotenuse, and the adjacent is here, which is 3, and the hypotenuse is here, which is 5. And following the triangle, the Pythagoras Theorem, we are going to have 5 squared minus 3 squared equal to 4 squared. So it will be 4 here. So we already know everything. So as we know that here is theta, then here will be 90 degree minus theta. Okay. Okay. So the first thing is we need to find the tangent theta. Tangent theta is suka tua, so tua. Okay, opposite over adjacent. Theta, opposite 4 over adjacent is 3. And for sine theta is SOH sine theta. This is the theta, opposite is 4, and the hypotenuse is 5. And the next one is cosecant. Cosecant theta is just equal to 1 over sine theta. And we already find the sine theta, which is this one. So 1 over 4 over 5, which is end up 5 over 4. And the last one is sine 90 degree. Sine 90 degree minus theta. And we need to look at this one. Focus here. The opposite sides of the angle is this one. This one, opposite side of that angle. So this is 3, and hypotenuse of it still this one. It's 5. So that's all. That's the equation for all the answer. That's the answer for all the equations. Okay, next one, number 3, given to you the cos x equal to 0.8. To be safe, you put it into fractions, which is come out with 4 over 5. And without using calculator, evaluate this whole thing. So we need the sine x, tangent x, and cosecant x information. So basically, you need a triangle, same like before. And this label as x because we have x here. Okay, we have x here. So it will be x here. Because that's the information given by the equation, you need to use it. And then the cos, as usual, cos. So cos 3. So adjacent here is 4 and hypotenuse is 5, and basically you know here 3, which is 5 squared minus 4 squared. You are going to have 3 squared. And then you need to have the sine x, and you know is SOH, so opposite over hypotenuse, opposite here 3 over 5 the hypotenuse, and the tangent x, and you have so cos 3 opposite over adjacent. The opposite is 3, the adjacent is 4. And then last one you have cosecant of x, which is 1 over sine x, and you already have sine x here, and it's end up 5 over 3. I skip one step. You already have all the information. Now you are going to solve that. 5 sine x minus 3 tangent x plus 3 cosecant x just equal to 5, and sine x 3 over 5 minus 3, your tangent will be 3 over 4, and your cosecant x will be 5 over 3, and this can be cancelled, and this one can be cancelled. Now you can use your calculator because it involves basic algebra. And lastly, you are going to have 23 over 4 as the final answer for this question. It's done.